we will move on to specifying the traction boundary conditions. Let me go back to that particular PowerPoint slide. So first we will specify the pressure due to the propellant, that's the hot gas. It's calculated using 1D gas dynamics, and the details are given in Andy's Excel file, which is provided to you as a download. And it varies in the axial direction. Okay, so it varies in this direction, and so I'll go back to mechanical and specify that pressure. Here's mechanical, and I will highlight static structural and select loads pressure. And I have to select all the faces that are exposed to the hot gas. So let me do that. I'll minimize this, I'll minimize this. And I will make sure that face selection filter is selected, select that. So let me select those faces. Those are the inside faces of the nozzle. So I'll select those first. Then there are faces, in this region that we need to select that are exposed to the hot gas. So first let's select the faces on the lower nozzle. Click on this surface and say, right click and say hide all other bodies. Click here and then hold down the control key and zoom in. So zoom in and then hold down the control key and select these faces. Okay, beyond this, we don't want gas to escape, so there's no pressure over there. And say apply. So you should have 8 faces now, and then there's a corresponding face on the upper nozzle. So let me go and say show all bodies. Click on this surface and say hide all other bodies. Click here. Then hold down the control key and click on this face and say apply. So that so that face is also exposed to the hot gas. And I'll say show all bodies. And for magnitude, I will say tabular, since I want it to vary in the z direction. And I'll bring the tabular data in. And I want it versus independent variable versus z. Okay, that's the axial coordinate. And at the exit, which is z equal to 0, the pressure is 12.17 psi. And make sure that you have the right units here. And then at the top, where the gas comes into the mid nozzle, we have the pressure as 47.72. Okay, and these values are given in the problem statement also. And then I can go in, and then I also need to specify that this is turned on in the second load step. So I'll go to graph controls and change x-axis to time and say that so in the first load step we don't apply the pressure, we just look at the effect of tightening the bolt or the bolt pretension, and then in the second load step it's turned on. So at the end of the second load step the pressure is applied, is completely applied. And then at the end of the third load step, and during the third load step, it stays on. And I can review that using the graph. So, if I bring the graph in and move this over here, it shows me that, okay, it's not turned on in the first load step. At the end of the second load step, it's fully applied. So when you're looking at the solution at the end of the second load step, you have the full effect of the pressure, and then you have it stays turned on in the third load step. And I can also look versus z. Okay, that's just giving me a graphical representation of that from 0 to 160. And if I minimize these, I can also see that if I zoom out, okay, it's giving me the variable load pressure, and for instance it says that the minimum value is here and it's around 12.17. so that's a good way to check, you know, that variable pressure. So I'll just zoom out here and zoom into the nozzle area and save file, save project.